A better analogy that I heard that I think is pretty cool. When you think of VM, think of a house. So when you have a house, you have your own driveway, own garage, own plumbing, heating, cooling, AC, backyard, front yard, whatnot. But when you think of container, think of it as an apartment building. So you have each apartment, they share the same underlying infrastructure, the same plumbing, the parking lot, the garage, the backyard, or whatever it might have. So everyone is sharing that. So I find that analogy to be very useful in distinguishing between a container and a VM. So how are Docker images made? Did you see that? So Docker images are pretty simple. They're made from Docker files. You have a file dictating what it should be done. So like this particular one, we're building an Apache server. So we're saying from Ubuntu version 16, but this is pretty much it. So it's really, really simple. Now that I explained to you what Docker is, Docker was not the first container technology. They had, container technology is pretty old. It's 20 years old, 30 years old, whatever it was. Other companies had it. But yeah.
Can we say the Oracle Solaris as a Docker technology on zones? Do you know the Solaris zone?
From Oracle?
Yeah.
Yeah. So Oracle really started it really, really early on.
Yeah.
So they containerized it. But all the other technology never really took off until Docker. It was just the cloud services exploding at that time. Docker came in and really took advantage of that. So you know what Docker is. Docker is a container runtime that's available. There are other container runtimes as well. Containerd, Cairo. You could get into a lot of politics about what's going on. So we won't waste too much time here. You probably heard of Kubernetes. Well, let me show. Kubernetes, Docker Swarm, Mesosphere, OpenShift. Could you lower the projector? Okay, that's fine. So it says Kubernetes, Docker Swarm, Mesosphere, OpenShift, and everything else. So what are they? So when Docker came on, it's really easy to deploy a container on one host. But now if you're a big organization and you want to deploy on many different hosts, thousands of hosts, you want to be able to manage it. Docker at that time was not able to manage it. So Google started a project called Kubernetes. Short-wise, they call it K8S. And what it did was, it's an orchestrator. It manages the container deployment. It manages the resource of the container. It brings it up, brings it down. So it helps you manage container environment across many different clusters, thousands of nodes. So it's really easy to manage all those clusters. Eventually, Docker came out with its own version called Docker Swarm. Had its own technology. It wasn't using Kubernetes originally. The Mesosphere had its own. OpenShift is more of a production enterprise level Kubernetes. Rancher had its own. Everyone had its own orchestrator at one point. But now all of these are all using Kubernetes. Docker Swarm, the latest version, has Swarm and Kubernetes. Rancher is using Kubernetes. Meso is using Kubernetes. A lot of people are starting to use Kubernetes as the orchestrator. So when you think about it, Kubernetes 1. This is a really old statistic. It's from 2017, but it's still, the point is very relevant. You can see on the Google monthly searches, 165,000 searches for Kubernetes, 33,000 for Docker. Look at the numbers are just amazing. GitHub commits 58,000 for Kubernetes, 3,000 for Docker Swarm. So Kubernetes is really taking over the orchestration level for containers. So what are the benefits? I spoke about this a little bit before. Containers really come up in seconds. They're massively scalable if you're using the right orchestrator. And they can run anywhere. As long as the kernel and the Docker engine is there, you'll be able to, you could download an Ubuntu. You can download a MySQL database image on your Ubuntu. You could take it on CentOS and do the same image, pull the same image, and run it there too. So you can pick it up and you can run it anywhere you want. So now that I gave you, I guess, a 101, a basic, really quick, high overview of what containers are, from Dockers to Kubernetes to the orchestrators and whatnot, I'll get into the talk that what we're going to discuss here about security. Why is security important in containers? A lot of people think, I have a container, it's containerized, it's isolated from everyone else, so it should be fine. There shouldn't be any vulnerability. The container world is all about microservices. Each container does a specific task. If you have a WordPress container, you could have a database WordPress container. You could have the web server or WordPress container. So each container is doing its job only. But it's a false belief. It's not secure. You're going to have problems with it. And traditional security products, like say Qualys or Tenable, one of those big guys that are out there, Nessus, they can't scan containers. Containers, they're up in seconds, they're down in seconds. So you can spin up a container and you can spin down a container. So if you're doing a traditional vulnerability scanning on a container, that container could come down before it even finishes a vulnerability scanning. And the whole idea about containers really is a little bit shift from traditional development. When you traditionally develop an application, you go through this testing, and after you deploy, you scan the image, you scan that application for vulnerability, you scan it for other issues that it might have. In container world, you bring that all the way to the left, so the whole shift left movement. You bring security to the developer side of the house, so like the DevSecOps part. So when you shift left and you bring security to the developer, as a developer builds his application or her application, when it goes through your CI/CD process, you should, after the build, scan the image at that time, not when it gets into production. When the application is in production, it's too late. It should be in a good state at that time. If you find a problem with it, you go back to your development, fix it in your development, and push out a new container. Because it only takes seconds for it to come up. It's very easy to do that. Best practice is you never update or edit a live production container. You take it offline, go back to your development, and then update it that time. Cool. So here are a couple of companies that got recently breached last year: Tesla, Jenkins, and Docker. By show of hand, do you guys know about these hacks? No. A few people. Okay. So what happened with Tesla? It was a Kubernetes misconfiguration. They left the console open. And what happened with that is they allowed hackers to get in and deploy crypto mining tools on it. And they were basically using Tesla's resources to mine for coins. Same thing with Jenkins. It was a misconfiguration. But they made $3 million, so those guys could afford to buy a Tesla. Then Docker Hub. It was in DockerCon, maybe second or third day of DockerCon. They did a release saying that we found images that had backdoor access. So when people deployed those images, hackers got notified and they were able to log on and deploy crypto mining tools. So in all three of these examples, these are major examples, but if you could Google containers breaches, you'll find there's so many examples of people getting hacked. And they're all pretty much doing crypto mining tools on it because it's easy and it's really untraceable, right? So the coin goes somewhere and someone makes money. Question?
Yeah, what do you mean by don't leave consoles open? Is that the physical machine that you're talking about? Or?
No, in the Kubernetes world, when you deploy a Kubernetes, you have an admin console, a control panel, and they just left it open without a password.
Okay, so if you're not deploying the UI, then this is not an issue.
Yeah, but we have, what you do is, there's like an open source project we have called KubeBench. You could take that and hit it against your Kubernetes environment, and it does a CIS benchmark to tell you what's open, what's not, what's the best practice. It gives you all that information. Good question. So when you deploy containers, what should you look for? What is the security that you're looking for? You're looking for security at the build time. Like I was saying before, it's best practice to integrate with your CI/CD tool, introduce security early on. So and this is what the vulnerability is. If there's a problem here, please go fix it. You don't wait till, you no longer have to wait for security or operation. Please stop what you're doing, go back and fix what you were doing before, and then continue on your regular job. Best practice is really to integrate early on. All the way to the left, the whole shift left movement. Integrate early on with your CI/CD tool and scan it. Scan your images for vulnerabilities. Then as you look at this pipeline and go to the other end, once that image that you have becomes a container, you want to make sure that it does what it's supposed to do. An example of Jenkins, is a CI/CD tool. You want that container to do CI/CD work, not crypto mining. If you have a MySQL database or MongoDB or Apache server, whatever it might be, you want it to do what it's supposed to do, nothing else. So you want to protect your runtime environment and make sure it's doing what it's supposed to do. In addition, you want to be able to say, hey, I scan my Nginx container here. I want to make sure that the same Nginx image that I scan here is what is being used to become a container. So we don't want anyone else after the scan to go into the image, update it, and add bad software to it. So you want to be able to check it to verify if the image is the same that you scanned it with, that you're running. If it's different, you need to be able to stop it and not allow it to run. So there's a couple of aspects to container security. So here's a good listing of, what are you protecting? Role containers. You don't want to deploy any unapproved images from your organization. So you don't want your developers, or developers shouldn't be able to go to Docker Hub, pull down CentOS image made by XYZ, and thinking it's the official CentOS image, but when in fact it has bad stuff in it. You want to be able to prevent drifting. Drifting means in a couple of ways. After the image is scanned, you want to make sure that nothing else was added to the image. And when the image becomes a container, you want to make sure that nothing else is added to that container that's not supposed to be there. I'm going to give you a live example of this and give you an opportunity to try to hack it or break it, so that'll be good. And you want to be able to protect the privilege inside the container. So, you don't want anyone to abuse their privileges, do something that they're not supposed to do. You don't want to be able to data exploitation, take data out. Network connection, you want to be able to control what a container is allowed to connect to. Typically, containers don't have a firewall like typical application or host servers do. So you want to be able to protect that. You want to be able to say, hey, this container could talk to this container at this port, or one container could talk to a website at this port or this URL or this IP address, and nothing else. So you should be able to control all that. And of course, you want to protect against zero-day attacks. Zero-day attacks, you don't know what they are. That's why they're zero-day attacks. They could do some damage, but you want to be able to protect your container environment against those type of attacks, or minimize those type of attacks. So I'm going to quickly jump into an actual demo now. Give me 1 second. you guys have any questions so far? Okay, there we go.
Are you going to share this presentation?
Yeah. Yeah, absolutely, we'll share it.
It's usually for $1 though, right?
No, it's 5.
Oh, you had to fly from Canada. I get it.
Exactly. Could you guys see my terminal?
No.
I have a question.
Yeah.
So how do you integrate this with like an existing Kubernetes cluster that you have up?
Sure. Yeah. So the product that I'm showing you is from the company I work for, Argo Security.
Yeah.
So the way we integrate with any orchestrator out there, we just deploy it as an application. There's a couple of components to it, but the main component is the enforcer. It's a container, it's a privileged container that gets deployed on your nodes, on your host, and that does all the protection. Now I didn't bring up an architecture diagram, but I could show you an architecture diagram afterwards to show you what it looks like and how easy it is to deploy. So we could deploy on regular Docker, Docker Swarm, Kubernetes, Mesos, Rancher, EKS, AKS, GKE, ECS. So we have CloudFormation templates, Helm charts, scripts to help you deploy this solution to your environment. It's really, really easy to deploy, as long as you have all the right permission and access. Okay, cool. So what I want to show you now, actually I'm going to bring down my machine if I do that. Okay, well, let's show you one here. Okay, anyone know what this is?
Still on the
Is what?
slides down.
Oh, why is that happening?
Means near.
Huh?
Near the.
Yeah, oh yeah, you're right. Oh, you know what? That's right.
Yeah.
Good idea. Sorry about that.
Almost like near.
Settings display.
Easiest.
All right. So anyone knows what that is? Yeah. So do you know what a fork bun does? Other than the guy who says a fork bun. So, actually, you know what? Let me just erase this and clear it out and make it a little bit bigger.
Enter a couple times.
A little bit of.
Oh, is it?
Here we go.
Okay. That. Take your laptops out and type that in. Just kidding. Don't do that. So what this is a fork bomb. What it's going to do is it's going to call itself over and over and over and over again and take up all the resources on your computer. You can do this on Windows, Mac, Linux, whatever. You can actually run this and it will bring down your system. So how do you protect that? Anyone could do this. So if I run this right now, this environment, I'll share the presentation with you, don't worry, you'll get it. If I run this, what would happen is my environment will go down. So let me just show you what this looks like.
Did you say that was called?
Fork, yeah, F-O-R-K, well. See, my environment is pretty fast, very responsive. I could do clear, date, whatever. Now if I do a fork bomb, it's actually going to kill this environment. Come on. So basically, it created itself. It's going to take all the resources. You can see what's happening there. So eventually, it's going to crash, and my system's going to go bad. Yeah, it's going to continue to call itself over and over and over again. So I just killed this environment now.
So you did in the container or in your
And you can do this is in a container, but you can do this on a host, you can do it anywhere. So this exploit is valid anywhere. So on a container, on a host, whatever. But yeah, so how do you protect against that, right? So this is a runtime protection. You need to be able to control how many processes an application could do. So if you're using a MySQL or MySQL application, you know what the process it has. Or another application, you know that, hey, it's never going to go over 100, especially in a container environment, because containers are isolated and they should not have anything else running. You can limit that. You can protect against that. Okay, I can't kill it here, but we'll go to the next one. Now, another exploit that happens really is, well, let me show you this first. I think this one makes more sense. 72.
For Unix, I guess there are some different parameters like max term. It allows you the maximum available. But the container is itself a process. It's a separate process of the operating system, and it's forking new threads as local applications.
Yeah.
Right? Yeah.
So
you can limit these numbers by the kernel parameters of Linux or Unix. There are some different attributes
yeah.
for each operating system.
Yeah. You could definitely go in there and limit it, and then when you do a Docker command or one command, you can limit the process at that time too, but it's more of a manual process. So when you use a utility like the way we have it with Aqua, you can prevent that from happening. And what I'll do now is, let me give you an overview of what you should do, and then go into a little bit more details on fork bomb, crypto mining, currency problems, hacks, and drift prevention and other protection. So this is our utility. So this is what I'm using to protect my containers. And so like I was saying before, the best practice is really to scan the images early on. So here's my Jenkins build. Here's my Jenkins build. In this Jenkins build, let me take a look at this application I have here, Orders Nginx. Look at this one here. So what we did here in this particular application, we added an Aqua scanner to it. It's available in the marketplace. You can just download it from the Jenkins marketplace, add the plugin there, and you can start scanning your images. So what's happening here is, let me go into the output. That might make more sense to you guys. You guys are familiar with Jenkins, right? I think a lot of you guys from the developer DevOps section. So here's the Jenkins here, and I'm creating this Docker file here. So it's not a major Docker file; it's a simple Docker file. And what's happening here is, when we build that image, we're calling our Aqua scanner to scan that image. So one of the last step of the build process is to scan it with Aqua. So that command is actually the command to run the scanner for Aqua, and it's scanning the image for any known vulnerabilities at that time. So when an application like Aqua scans it, it takes the image, rips it apart, calculates the hashes of each of the components, and contacts our cyber center and basically asks the cyber center, hey, does any of these hashes have any vulnerabilities associated with them? If yes, what are they? And go ahead and list it. And then you apply a policy that you set up within Aqua UI to tell it what to do. So again, like the best practice is from the left. You bring in, you're scanning an image, you're doing a vulnerability scanning on that particular image. We have a free tool called a micro scanner. It's a free scanning tool available on GitHub, so you can just go there and pull it down. I have links at the end of it to show you what that looks like. So when you scan an image and you fail the image, the developer gets notified that their project failed because of the security vulnerability. They could come back to the build cycle, check out what the vulnerability is, and this fail the custom check, fail word writable file. So in my policy, I build an image that says that, hey, I want you to fail this particular type of, if there's any world writable files on that image, I want you to fail it. So in Unix term, anything that has a chmod 777 on, you don't want to deploy that to production. There's something writable for anyone. So you want to prevent that from happening. Now let me go back to the Aqua side of the house. Let me just shut this one off. That's okay. Yeah, questions?
So can you cache, can you download the DB or the database that has all these vulnerabilities and kind of just reference a cached version, on premises? Or you have to always talk to...
No, a good question. So if you're using a micro scanner, the free version, you can't do that. Okay. But if you were to purchase Aqua, you have the ability to bring that down as a container to your local environment as well. I'll show you, I wanted to make this as generic as possible, but at the end, I'll show you an architect diagram of how Aqua looks like, how it gets deployed, what are the components, and how it all works together. But in generic terms, yeah, you'll be able to bring it down. But keep in mind, if you use a cache version, it gets updated daily. So your cache version from today, and if you try to use it tomorrow, is already outdated. The new vulnerability is coming up every single day. If you look at the CVE marking, yeah, they are labeled by 2019, by the year, and then what number of that vulnerability is. It's already in the thousands. Yeah?
I have two questions. The first was, is it scanning the image in the registry or on the local cache?
It could do both, but in that case I was showing you, it's scanning the actual image on that local environment.
Okay. Yeah. And the second question is, does it work with multi-stage builds?
It does work with what?
Sorry, multi-stage builds.
Multi-stage builds, yeah. So it's up to you when you want to put that scanner in there. You can wait till the end of the whole completed build, or each stages of the build. So you can add it whenever you want to add it. So, if you want to add at the beginning, when you pull down the base image, and you could fail that base image if it has high vulnerability, low vulnerabilities, or whatever, you could definitely do that. How are we with time? Are we okay?
Okay.
Cool. So, for example, here's one image here. Let's go back here. So the question someone had early on, with Tesla and all those people that had their Kubernetes environment open, this is our CIS benchmark. This CIS benchmark will work daily and check your environment to see if you have anything configured incorrectly. So it tells you, this one failed. It failed because of lock privilege or whatever it might be. So the CIS benchmark will run and tell you what the problem is. So if you were Tesla or any of those other companies, you could have used the CIS benchmark or use our free Kubebench tool to figure out what your environment is and protect it that way. So that's one thing. And what I want to show you here is what an image scan looks like. So let's just open one up. So when you scan an image, like this particular image that we just scanned, it failed the CVE blacklist. I changed the policy a little bit right now just to reset it to the original state than what I showed you in Jenkins. But it's still fine. Still fine. So in this particular image, it failed it because it has a CVE blacklist. So we're blacklisting, in our policy, we're blacklisting a particular CVE. I don't care if it's a high, medium, or low. I'm just blocking a particular CVE. So using a tool like Aqua or any other tool, you get a list of what the vulnerabilities are. So when you scan your image at build, it'll tell you that, hey, these are the vulnerabilities. And due to the policy that you set up in Aqua, it failed because of X, Y, Z. In this case, what I'm showing you right now, it failed because it matched this particular CVE. We'll tell you what the description, the solution, the fixed version are, and you can go ahead and take action against it. So that's one thing. So this is how you integrate with Jenkins. This is how you do an image scan. So if I go here, let me just kill this one. I can manually scan an image as well here. So for my Docker Hub, I could go get CentOS. And then it's going to go ahead and download and start scanning my CentOS image. Or a CentOS image, not mine, but the one I got from my Docker Hub or any registry that I configured. So if you want to check for something, this is a good way. Here's a scan of CentOS 5. It has 20 high vulnerabilities. Come on. It has 20 high vulnerabilities, 15 medium. So it gives you a good list of what the vulnerabilities are. And this is a file, not a package. Here's an RPM package. So we could go deep down and look at all the files, what they are. Here's one telling what the fixed version is. And if you want to acknowledge it and say like, yeah, I'm okay with this, you could go ahead and acknowledge it, saying that this one shouldn't be a reason why it should fail. This is good to go. So that's image scanning. What I want to show you now is a runtime protection. Let me see if we can get back on there. Okay, we'll just try it here. No problem. So remember in the beginning I was showing the slide with the pipeline. You do your image scanning and then you protect the image at runtime. So we just did the image scanning. We got a list of vulnerabilities for that particular image. So now we're going to go take a look at runtime. For runtime, you can build policies to control what an image does. And what I'm going to show you here is two controls. One is the executable blacklist, and the other is the drift prevention. In the executable blacklist, I'm blacklisting bin PS from running. And the drift prevention I have enabled, I'm going to prevent any executable that was not in the original image from running. So think about it, if the crypto mining tool wasn't in there, it shouldn't be able to run. Okay, so my VPN is back up online, so I can go ahead and stop this. Let's go back here. Okay, so do Docker PS. So I'm going to Docker exec into an application here, my WordPress application. So I'm in there. I can do clear. Who am I? Works, date, if I can spell right, there we go. Now if I type in PS, I get permission denied, even though I'm root. So I'm protecting this container by not allowing PS to run. You can add any executable you want. You can add NC or curl or VI or whatever, nano. You can add those executable as a blacklist, so you prevent anyone from running those executable, even though you logged in as root. So that's one thing. Now I want to show you what drift prevention looks like. I can ping localhost, it's working fine. It's in my bin directory. So I'm going to copy ping to Pong. So now I have Pong and ping and Pong here. Pong is the exact same copy of ping. And I get permission denied. This is where you clap. There we go. Just make sure you're awake. Cool. So, thank you. So what happened here was Pong was not in the original image. So therefore, Aqua is going to block that from running. So if you think about it as, if I was a hacker and I download a crypto mining tool to a running container, like what happened with Tesla, like what happened with Jenkins, and like what happened with those Docker images, I need protection against that. So even if a hacker broke in, they're not going to be able to execute that script that they got, that executable they have. Aqua is going to block it. That's how we do it. A few questions comes up here is like, are we just looking at the name? What if I rename a bad executable as a good executable? Like rename a bad executable as ping. What would happen?
Just link in.
What was that?
Just link with something in.
Something bad, you rename it?
Link. Something.
Yeah, like a symbolic
Something.
link.
A symbolic link. Yeah, so symbolic link, symlink won't work either because symlink actually points to the original executable anyway, so it's not going to work. But yeah.
So how exactly are like the commands like being stopped? Is there like an agent that's injected by the Aqua container, like to all your containers that are running on the cluster? Or?
Yeah, no, Aqua doesn't inject anything into a container. So we have an enforcer that gets deployed on the host that's actually providing that protection. So it's one enforcer, one container to a number of containers that you have, application containers.
Okay.
So all those application containers communicate through the Docker commands, through Docker APIs and whatnot, and Aqua is able to see what's going on and block that from happening if it's not allowed to happen.
Okay.
So what I'm going to do is I'm going to move ping to ping org, and you can see that date works. Date is an allowed executable. So I'm going to copy date to ping. So date was an allowed executable. Ping was an allowed executable. So I just copied date to ping. And if I type in ping, I'll still get permission denied. So this is how you protect your application, your running container from drift. Making sure that it does what it's supposed to do. This is just one way. While I'm here, let me show you another thing. Here's my resources that are happening on this container. It's pretty simple, nothing happening. It's nice and clean. Oh, you don't see the top part. Here's a Python script that we wrote that breaks into a WordPress container. Because you know how secure WordPress containers are, right? So it's really hard to break into it. But we figured it out. And then we download a crypto mining tool to it, and we try to execute that crypto mining tool. And you get permission denied. So I didn't say to block that particular executable. I just had that one checkbox enabled in my profile for runtime, drift prevention. Just one checkbox. It didn't need to learn it. It didn't need to monitor it. It didn't need to do anything. As you scanned your image in originally, Aqua took a catalog of all the executables, calculated the hash of all the executables, figured out what the path is. There's a whole bunch of stuff Aqua does and puts it all together, and then it's in the database. So now that information is there, if you try to run something that's not that Aqua had before, it's going to block it. So it's pretty simple the way it works. This is my demo system, so I could do stuff that wouldn't be allowed otherwise. I just turn off my security, and I'm going to try to run this exploit again. And hopefully this time it should run. So I broke into the WordPress container, we downloaded a miner, and the miner executed properly. So if I go back into my container, and I look at top, you can see 99.4%, 92%. So this is actually live doing crypto mining right now. And Andrea is making her retirement money off of this. 1/1000th of a penny or something. So let's get out of here. All right, let me just. Any questions so far while I bring this back up?
Any questions? No? Nothing?
Cool.
So,
So that's one way to look at it. And the other,
Just one thing, what's the overhead it's going to be an overhead, it's certain, and if it's an overhead, it works it. But is that going to be a bottleneck for my environment?
yeah, a good question, right? So that question is hard to answer because it all depends on your environment. In particular to Aqua, we have a sizing guide, but our customers have done their own testing, and every customer is different. Depending on how big the image is, how much is being used, how big the server is, how much RAM it has, how fast the CPU is. So it varies. But from what my customers have done, overhead was 0.8 to 1.2% overhead on their environment. This is too small for us to care about. So it wasn't that big. But then again, if if you have millions of containers coming up and down, it might be a little bit different. But cool. So what I just showed you is the drift prevention and blacklist executable. So going back to the example that I gave you before, Tesla, Jenkins, and Docker, and many others, and those that are not listed yet. This is how you can protect your container from like zero-day attack, from making sure that the container does what it's supposed to do and nothing else. There's one more thing I want to show you, and then
Question.
yeah.
So if during the runtime, if a malicious activity is detected, is there a way to like quarantine that container and do you get alerted on that, or how does that work?
Yeah, so there's no quarantine way, but you get an alert, a log gets generated, an alert gets generated, and you get notified to like PagerDuty, Slack, or other channels. But remember, that malicious attack won't run. It won't be allowed to run. But you get an alert on it, and then you can take action as you need it. So you never want to take down a running container that might be mission critical to the customer. It's a revenue generating application. It's a credit card process or website or something. You wouldn't want CNN or New York Times or eBay or Amazon to take their front web page off, right? So what I want to show you one more thing is the policy that I showed you is very generic. It gets applied to everyone. You can take it a step further and do it for that particular image. So if I look at my images here, I have like MySQL here. We have something called an image profile. An image profile tells Aqua that this image is a MySQL application and it's only allowed to do these 5 or 10 executable and nothing else. So if you look at the setting, I didn't choose a profile.
So are you guys in the business of providing proper security or proper images that are secure?
No.
Okay.
Yeah, so the images is your own images. The developer, the organization, they make their own images however they want to. We're going to scan that image and make sure it's nice and clean. And it does what it's supposed to do. For example, here's an image profile for MySQL application. MySQL application is a simple application. We know what the executables are. We know what it's supposed to do. In this case, I'm going to deny all outbound connection, but I'm going to allow inbound connection. Here's my allowed executable. These are the executables that are allowed to run and nothing else. This is an easy, simple example. Your applications are much more complicated. Like you had a multi-stage application. So you're building a bunch of components together and making a big application that's very complicated. So what you want to do is, you might not know, as a security professional, you don't know what the application is supposed to do. You can't burden the developer to tell you, hey, what are all the executable that this application needs to run? That's not practical, that's not feasible. What you could do, at least with this product, is you can have Aqua watch that container, a running container, and build a profile for you automatically. So let me just show you one.
a kind of learning process.
Yeah, so you can learn the behavior of an application. We use basic machine learning to monitor the running application over a set period of time, and it'll generate that profile, that least privileged profile for you. By default, it's 24 hours. So let me go ahead and run one right now. Okay. I wrote a script. So what's going to happen now is it's going to do this Docker run command and bring up the container, the JBoss Wildfly container, and Aqua is going to start watching this. So let's just go ahead and refresh here. You can see there's a little record icon showing up here. So in the last 10, 15 seconds or so of the application running, it's doing these executables. This is the min-max average CPU and memory. We capture the network calls if there's any, system calls, environment variables, and the user account that's being used to run the application. So this is, by default, we're set to 24 hours. So stay put for 24 hours. We'll start this again tomorrow. Cool? Okay, but you can change that timing to whatever you want. 10 minutes, 1 hour, 48 hours. It doesn't matter. You can do what you like. I'm gonna go ahead and kill it right now. And because this is my script and a demo, this is what a profile looks like. So Aqua, by watching that container over the last 40, 50 seconds, it generated this profile. This is a least privileged profile. This is a least privileges that container needs to run, to do what it needs to do. Let me go here. And you can see the profile has been already attached. So this is all automatic. You don't have to do anything. Aqua will watch it and do it. Why this is important? Because instead of the generic runtime profile I showed you before, this is explicitly to this particular image. So any container that gets built based on that image could only do these executables only, and these system calls, and this drift prevention. So and that user who could only be allowed to use to log in. So let's go ahead and show you what that looks like. Hopefully my environment will cooperate. So I get permission denied. I try to sudo docker exec with a root access and with the user root. I got permission denied. The reason why I got permission denied was root was not allowed to, was not the user that was being used to run that application. And this is really good practice because you don't want your container to run as root. You don't want your container to run as an administrator for Windows container. Those users have too much power, too much privilege. They could do real damage. So you want to restrict that from happening. So now I logged in, and you can see I'm in my container, but I'm getting all these other permission denied. I'm getting these permission denied because on my profile, those executables were not there. So it blocked them. Now, if I'm a hacker and I get into this environment, there's no way, or not that I know of, that they could tell that this is a container. All they could tell is, oh wow, I got a command shell. What could I do here? So let me go ahead and do ls. Oh, permission denied. No problem. Let me just do a vi hackme.sh. Permission denied. Well, you know what? I can do a curl something. I'm going to download my thing. Permission denied. Who am I? Permission denied. Clear. Permission denied. So think about what just happened here. even though those executables are on the image, and most images are not clean images, they use a heavy Linux-based image, like a CentOS or Ubuntu or something like that. Not many people use Alpine images. So they have a lot of executables that you don't need, your application does not need. So what we just did here is we removed those attack vectors there. Those executables are not allowed to run, so you can't exploit those executables. Now let me go back here and let me add a few executables here. So let me go ahead and add user bin ls. So I just added ls and who am I, and just to make sure that, just to prove that I'm not doing any magic or anything mischievous. Look, I could type in ls, it doesn't work. Who am I? It doesn't work. So I'm still in my container. I'm going to go back here, click on save. ls works. Audit. So you want, for your security compliance things, you want to be able to log in and check out the audit log, to check out the what happened. If my net, what happened? So everything is logged, everything is auditable. So you can see a few logs here, blocks. Here's what policy blocked it. So all that is blocked. And you can link this up to your SIM or analytics tool and automatically, let me go back to the presentation here. Integrate early on, how to use the best practice, scan an image at build time, protect your container at runtime, showed you how those hacks that happened with Tesla, Kubernetes, Jenkins, Docker, and whatnot, how you can protect yourself against that. And what I want to show you now is a few open source projects that we have. You can just go to our website. This will be shared with you so you can get the URL. We have KubeBench. KubeBench is a benchmark against CIS benchmark to check your environment to see how good it is. KubeHunter is pretty cool. I want to do a demonstration of that as well. What KubeHunter does is it checks your Kubernetes environment. It's like a penetration testing tool for your Kubernetes environment. You can actually run it against other environments, but I recommend you to run only against what you have authorized to do. And then our micro scanner. That's our free scanning tool that's available for you to start scanning your images, for free right away. So I'm going to quickly show you the KubeHunter. So here's our KubeHunter website. You guys can just go to cube-hunter.aquasec.com. And what it does is really a few tests, a bunch of passive tests and a bunch of active tests against your Kubernetes environment. And this is open source, so it gets updated every time, every day, and you could actually contribute to the code here. So I'm going to go ahead and run it. So it's really easy to run. Just type in your email address here and click on Get Started. It'll generate a Docker run command. So let me just. And here's the Docker run command gets generated. Copy this. Go to your Kubernetes environment. I'll just do it here. Paste it and run it. And now it's going to ask you if you want to do remote scanning, something, or IP range scanning. Remote could be any remote Kubernetes environment you want to check. 2 will be your local scanning, so I'm going to do it on my own environment. And then it's going to run through all the testings here. It's going to check everything out, and it's going to generate a URL, and then you can view your results over there. And there it is. I should be able to click it here. Yep. So on my environment, I have no vulnerabilities. I have a 4-node environment, master, and you can see that all my nodes are pretty clean. So this is actually on I think this is on Azure, so they have a good environment. But if you did it on your local Kubernetes environment, you can test it out. You can see if you left anything open, and you can free to see what problems you might have.
How is this tool updates on vulnerable database, signature or something? Is that getting some?
Yeah, so this is not looking for any vulnerability like CVEs or anything. This is actually doing a penetration testing. So when you run the Docker run command, it pulls down the latest test that it has, and it runs against that. It's actually on GitHub, so you can go look at the source code. You can see what it's testing, and you can add more to it if you want. Cool. I think I'm done with my presentation. So if you have any questions, and I know you guys wanted to see the architect diagram, I can bring that up. But if you have any other questions before we get there.
Questions, now's the time. Raise that hand. No?
What were companies using before something like this? Like, I haven't worked in a big Dockerized container platform, but was there a solution before, or how did people do this manually?
Prayers.
Prayers.
I hope they don't get attacked.
Got it.
So, I mean, when you think about it, a lot of companies are going into the container world. They started last year, they're really moving forward this year, so it's really picking up this year. So maybe earlier companies thought that, hey, not many people are doing this, I'm okay, it's not that prevalent. So, but you saw what happened with Tesla, you saw what happened with Jenkins. You could just Google the Tesla Kubernetes hack, it's all over the news, so not a problem. This is just our marketing architecture, so think of it as a marketecture. There are a few components to Aqua. The Aqua Command Center, the UI that we were working with. Then we have the gateway, and then the enforcer. The enforcer, think of the enforcer as the police force. They're going to enforce the rules that you set up within the command center. Each of these components are containers. So they get deployed on your container environment, either be on-prem or in the cloud. It doesn't matter. So wherever it is, you could be using Kubernetes, you could be using Docker, Mesos, Rancher, anything really, or any orchestrator, you can deploy this.
What other companies or tools, your competitors,
Yeah, so more and more competitors are coming every single day because they just realize that, hey, this is a great market. Like big companies like Qualys are getting into this. Tenable tried to get into this, but they did a really bad job. I was at a conference and people from Qualys were asking me, hey, how do you do this? Tell us, how do you do this? And the guy's like, I've been trying to do this, I couldn't get this to work, and I'm a developer and whatnot, but yeah, so there are competitors there. There are competitors that take different approach. They do just scanning, or they look at the network traffic part of it because they're coming from the network background, so they do the network part. But not many companies do the whole cycle, and very few companies do the runtime protection on running containers like the way we do it, especially without the learning. That one little checkbox, the drift prevention checkbox, is super powerful. Yeah.
What was the difference between the KubeBench and the KubeHunter? I wasn't sure if I really.
Sure.
Yeah, that was really good, clear for me.
KubeBench is our benchmark utility against the CIS benchmark. So it's mostly for compliance purposes. So KubeBench could tell you that, hey, that this is open and you should probably take a look at it. But KubeHunter will actually go and try to hack your environment and say, this is how a hacker could break into your environment. So you probably want to take a look at this.
Gotcha. Okay.
So think of KubeBench as KubeHunter as a penetration testing tool.
So you're giving all those recommendations